6 points are numbered as shown. Christian draws true triangles and colors them. One of the triangles join the even numbered point and the other triangle joins the odd number points. Which of the 5 options shows the drawing of Christian? Let us connect these points. So we connect odd numbers together. So we have this odd numbers and then we connect even numbers. Now, which of the 5 functions shows the drawing of Christian? That is option E. Problem 2. Eileen wrote 5 buoys as shown. Which buoys did Eileen row around in a counterclockwise direction? And these are our options. So Eileen starts from here, and that is the first one, goes this way, and then it goes in this direction, that goes clockwise. So this is the one which goes anti-clockwise, so this is one option. And then we moved and this goes in a anti-clockwise again. So this is second, and then we move here and that goes in this direction, that is clockwise, that is clockwise, and then it comes here. So we have option 1 and 3. That is our answer, option E. Problem 3. Laser beams reflect in mirrors in the way shown in the picture on the right. At which letter will this laser beam end up? These are our options. So laser beams goes from here, it reflects and goes out. So this is the reflection pattern it used. So let us start. So it reflects from here, it reflects from this mirror, goes to right, reflect downwards, reflect left, come down, reflect towards right, reflects upward, reflect right, upward, right, down, reflect left, come down, reflect left, and it comes out of B. So B is our answer. Problem 4. Which of the following fractions of a whole turn should the Ferris wheel turn to bring a white cabin to the top? So this is the white cabin which needs to bring it up here. And these are our options. If you look into this Ferris wheel, it will reflect as a clock. So this is the base of the clock, and if we mark it as 12, we say 1, 2, 3, 4, 5, 6, 7, 8. Let's mark 7 too. Don't leave it. 9, 10, and 11. And this Ferris wheel has to go from here to here. That means he has to pass one cycle. So we say 1 by 12. And our answer is D, 1 by 12. Problem 5. Marbles are sold in packages of 5, 10, and 25. Tom buys exactly 95 marbles. What is the minimum number of packages he could buy? These are our options. So we have to find the minimum number of package he could buy through these numbers 5, 10, and 25. So let us consider the biggest pack. So we have 25. So use 25 plus 25 gives us 50. 50 plus 25 gives us 75. And we cannot go beyond because it will pass 95. So we'll use 3 packs of 25. So it makes it 75 packs. Now how much left? We have left with 95 minus 75 gives us 20 marbles left. Now how can we use 5, 10 with 20? We can make 2 packs of 10. So we get 10 packs plus 10 packs. Now we have used all the marbles. So let's count. We have 1 pack, 2 pack, 3 pack, 4 pack, and 5 pack. So we have used 5 packs. Our answer is option B, 5. Problem 6. Bodil rearranges the 7 pieces shown to get the smallest possible 12-digit number. What are the 3 rightmost digits of this number? These are our numbers. We have to form a smallest possible 12-digit number. And these are our options. So what's the key idea here? So if a number starts from the lowest digit number, that would be the smallest one. So if a number starts from 1 and then 2 and 3, 4, that would form a smallest digit number. So let's see these numbers and see which one we could pick first. So we have 1 in here. We pick 113. Now, which one is 2? We don't have. 3 we don't have. We have 4. So let's pick 4. 5. So we have 2 5, 51 and 5. So 5 is smaller than 51. So we pick 5 and then we pick 51. Now after 5 we have 6. So we have 2 6, 67 and 69. So 67 is less than 69. So we pick 67 and then 69. Then 7 we don't have, 8 we don't have, we have 9. And this is the way we have picked all our 7 pieces together and form a smallest possible 12-digit number. So now question says, what are the 3 rightmost digits of this number? So we have a 699. That is the rightmost digit and our answer is option A. Problem 7. In the garage shown, vehicles can only move forward or backward. They cannot turn. What is the fewest number of vehicles that have to move so that the black car can exit the garage? These are our options. This is from one of my favorite games while growing up. It's called Rush Hour. So let us find it out how many moves we have to do to have this black car move out of the garage. So first, let's have some space here so this can be moved. So how we can have the space? We move this 1, we move 2, then we move this one here, 3, and this one comes down here, 4, and that's how we could take it out. So our answer is option C, 4. Problem 8. Julia has one long strand of spaghetti she needs to make smaller. Every time she breaks one piece of spaghetti, it becomes 3 pieces as shown in the picture. Which of the following numbers, if pieces, could she not get? These are our options. So we know that Julia starts with one long piece of spaghetti. Each time she breaks one piece, it turns into 3 pieces. We want to figure out which number of pieces is not possible to get by doing this repeatedly. Now we start with one piece. One piece gives us 3 pieces. Now we do 1 pieces of this will give us 3 pieces. So we got 1, 2, 3 and 2 old ones. That makes us 5 pieces. Again, we do 3 pieces for this one. So we had 5 pieces earlier. We added 2 new. So makes it 7 pieces now. Again, we break this in 3 pieces. So we had 7 pieces. We added 2 new pieces. So it makes it 9 pieces. Similarly, we have 9 pieces. We added 2 new pieces, make it 11 pieces. 11 pieces, added 2 new pieces, gives us 13 pieces. And 13 old pieces and added 2 new pieces gives us 15 pieces, and so on. So you see a pattern in here. You see we have 3, 5, 7, 9, 11, 13, 15. So each pieces breaks at 2 more pieces and it gives us a series of pattern. So here is our series 1, 3, 5, 7, 9 and so on. Now we have to find out which pieces could she not get. Also looking into the series, what do you get? We understood that the gap between them is of 2 and this is a series of odd numbers. So definitely any even numbers would not be the number in this series. So can we get 13? Yes. Can we get 17? Yes, that would be the next. 20. This is an even number and this could be our answer. 23, yes, we could get. 25, we could get. So our answer is option C, 20. Problem 9. In the diagram, the square ABCD has side length of 10 centimeter. This is our square. What is the area of the shaded part of the square? These are our options. We have the side of the square given 10 centimeter each. 10 centimeter here, 10 centimeter and 10 centimeter. So with this length, can we determine the area of the square? Length into width, that is 10 multiplied by 10 gives us 100 square centimeter. Now we have the area of the entire square. Now if you observe this picture, would you agree with me that the area of this is same as area of this? Area of this is same as this. And this area completely is same as this. So can we reposition this and corner to one place? So we moved this area in here and fill it with gray. This gray we can move in here. Now we have this, we can reposition this one, so we fill it. So now we have complete half of the square filled with gray. Since we have the complete area is 100 square centimeter, what would be the half area of a square? That is 50 square centimeter. This is our option C. Problem 10. 60 tiles are laid in a long line. First, Adam removes every 6th tile. Next, Butter removes every 5th tile from the remaining tiles. Then Caleb comes and removes every 4th tile from the remaining tiles. Finally, Doris removes all the remaining tiles. How many tiles does Doris remove? These are our options. Let us go along with this question and divide Adam, Berta and Caleb. We know that there were 60 tiles initially. Then first Adam removes every 6th tile. So 60 tiles are divided in segments of 6th tile. So we say 60 divided by 6 gets us 10 tiles. So the 10 tiles were removed from the stake of 60 tiles. How many tiles remain? 60 minus 10 gives us 50 tiles. Now next Barta comes and she removes every 5th tile from the remaining tiles. That means 50 divided by 5 gives us 10 tiles. How many tiles are left? 50 minus 10 gives us 40. Now Caleb comes and removes every 4th tile from the remaining tiles. That means 40 divided by 4 gives us 10 tiles. How many tiles are left? 40 minus 10 gives us 30. So Doris removes all the remaining tiles, which is 30 tiles. So our answer is option C, 30. With this, you have finished part A of the 2022 Math Kangaroo Challenge for grade 5 and 6 together. You guys have done an amazing job. If you really enjoy solving these puzzles, please do not forget to subscribe for more math challenges. And make sure to check out part B of 2022 Math Kangaroo Challenge for grade 5 and 6. See you in the next video. Thank you.